Hello and welcome to this video on mortgages. We have that a $160,000 loan mortgage was amortized over 20 years by monthly repayments. The interest rate on the mortgage was fixed at 5.5% compounded semi-annually for the entire period. We need to first calculate the size of the payments rounded up to the next $100, and second, calculate the size of the final payment using the payment from Part A. And we need to round the answer to the nearest cent. To work with this problem, we need to understand that the loan is in the form of an ordinary general annuity, as payments are made at the end of each payment period, which is monthly, and the compounding period, which is semi-annually, and the payment period, which is monthly, are not the same. So we can compute the periodic interest rate by doing I equals it's right here. I equals J over M, where J is 5.5% and M is 2, because we have that interest is compounded semi-annually, so the number of compounding periods per year is 2. And we obtain the number 0.0275. So the number of compounding periods per year divided by the number of payments per year is 2 divided by 12. We have 2 compounding periods per year, and there are 12 payments per year in total because the payments are made monthly. So we have 1 over 6. That the effective interest rate turns out to be I2 equals 1 plus I to the C minus 1. So we do 1 plus 0.0275 to the 1 over 6 minus 1. Okay. So there we have that. Now to work with Part A, we use a formula. Let's see, for Part A, to calculate the size of the payments rounded up to the next $100, we make the future value of the loan equal to the payment size multiplied by the 1 minus 1 plus I2 to the negative 240 divided by I2. And this is the present value of the annuity. And the 240 comes from multiplying 12 payments by 20 years. So this 240 is the number of payments that are made in 20 years, and we have 20 years, and then 12 payments made each year. So PMT turns out to be 160,000 multiplied by I2, and all that gets divided by 1 minus 1 plus I2 to the minus 240. We could use a calculator to compute this value with I2 equal to this expression. And when we use a calculator, we get the value 1095.03. About that value, this weird equal means approximately equal to. And to round these up to the next $100, we get $1,100. Okay. This is the answer to Part A. We use the formula present value of the loan equals present value of the annuity, and then solve for the payment size. And we get about $1,100. Then for part B, to calculate the size of the final payment using the payment from part A, we need to know how many payments we need to make to cover the loan of $160,000, and the payment we're making every month is $1,100. To find that number of payments, we use a formula from the chapter on annuities. We have minus the loan, natural logarithm of 1 minus, and we're covering I2 multiplied by 160,000. So we always do I2 times the balance divided by the payment. So 1,100. And we divide the natural logarithm of that expression by the natural logarithm of 1 plus I2. And remember that this is I2. And when we compute that value, we get approximately 238.049, which corresponds to 239 payments. We need an integer as n. And with this information, so we need to make 239 payments of we get to cover those $160,000 loan. To settle that amount in 239, in about 239 payments, 238 of which are $1,100, and the final amount, the final payment we need to make comes from taking the future value of the $160,000 in 238 payments minus the future value of the annuity in 238 payments and all this gets multiplied by 1 plus I2. This is a formula that we have from our chapter on amortization. To find the final payment, we compute the future value of the loan after, so in this case 239, we have 239 minus 1, so after 238 payments, minus the future value of the annuity after 238 payments, all that multiplied by 1 plus I2. And when we use a calculator to compute this value, we'll get approximately 53.6. So there we have the answer to part B. Answer to B. Okay, so that's it for this video. If you have questions, please write a comment and let me know, and I will try to help you. I hope you enjoyed this video. Bye bye.